Hello, and welcome to a little video about using sine, cosine, and tangent on the unit circle. So, let's begin by considering the triangle at some sort of degree starting in the middle of the circle at the origin, and just forming a beautiful right triangle. Now, we've talked about several different degree measures, especially in that first quadrant. We talked about our reference angles, 30, 45, and 60. Well, what if it wasn't a reference angle? How would we solve? Well, let's check out this triangle to kind of help us see sine and cosine of any angle on the unit circle. Okay, so here is our beautiful triangle. My hypotenuse is labeled as 1 because this is a unit circle. The radius here is 1. The bottom here, the base of my triangle, I don't know what it is, but it is on the x-axis, so I'm calling it x. And then the height is y because it's parallel to the y-axis, it's vertical. It's some amount of y's. I don't know what it is, but it forms a point x comma y. Now, if we're thinking about right angle trigonometry using sine, cosine, and tangent, we need to label all of our sides as opposite, adjacent, and hypotenuse. So let's do that. Let's begin with hypotenuse because I think that's the easiest one. This is the hypotenuse. It is always across from the right angle. Boom, there we are. Okay, next let's take a look at opposite. I think that's the easiest next one to find. So if I look at my angle and I go opposite it, the side here is y, so OPP for opposite, because, we're using zeros and stuff. I don't want to confuse you. And lastly, of course, we're left with adjacent. That would be here. Adj. Okay. Now, at the beginning of this unit, we talked about SOHCAHTOA, right? And sine was opposite over hypotenuse. So let's write that down. Opposite, O for opposite, let's do OPP, just in case, over H for hypotenuse. Okay, well, let's check out our values. For sine, or in the circle, the opposite value is y. Our hypotenuse is 1. Y divided by 1 is y. So our sine tells us our y coordinate. Interesting. Let's take a peek at cosine. Cosine is adjacent over hypotenuse. In this triangle, adjacent is x, hypotenuse is 1, x divided by 1 is x. Fantastic. So when we are finding the sine of any angle, we are really finding the y coordinate on the graph. If we're finding the cosine of any angle, we're actually finding the x-coordinate on the graph. Let's transfer that to the unit circle. Here it is. All of our unit circle values are labeled. I have my references angles, the same color as the angles that it references. So we have our 30, 150, 210, 330. All marked in pink. The 45s are marked in yellow, the 60s in purple, and of course our 90-degree ones are marked in green. In every single one of these, the coordinates represent the sine and cosine of that angle. The best way that I've found to remember this is that when we're writing our coordinates, we go x comma y, and that's alphabetical order. Same thing goes for sine and cosine. C comes before S, so alphabetical order. Cosine, sine. So let's say I asked you, hey, what is the cosine of 150 degrees? Well, you would look at 150, look at its points, and tell me the x-coordinate, negative square root of 3 over 2. If I said, hey, what is the sine of 45 degrees? Let's find 45. There it is. Sine means my y coordinate, root 2 over 2. Let's do a couple examples down here. Okay, So we're going to use the unit circle that's beautifully filled in and highlighted now to answer the following questions. First, let's take a look at sine of 210. What that problem is actually trying to say is, what is the y-coordinate at 210? All right, well, the y-coordinates we have are green. So let's check it out. Let's find 210. Oops, my bad. Let's find 210. There it is. Let's find its y-coordinate, -1/2. So sine of 210 is -1/2. Let's do the same thing for 330. Sine of 330. Once again, we're looking for the y-coordinate at 330. Well, let's take a look. Here's 330. Y-coordinate is -√3/2. And let's write that down. I need to zoom in for that. -√3/2. Let's continue. Cosine of 150. Okay, cosine is not our y-coordinate. Cosine is our x. So what I'm really asking you with C is, what is the x-coordinate at 150? So let's look at it. There's 150. Let's look at x. -√3/2. Yeah, we have repeating answers, but there's only so many variations that we have with these, I guess, these perfect quote-unquote angles of the unit circle. Lastly, cosine of 240. That's actually asking us, what is the x-coordinate at 240 degrees? Let's check it out. There's 240. The x is -1/2. All right, and that is it. Is it really as simple as looking at the x's and y's on our unit circle? Indeed. Will using a calculator set in degree mode give you the same answers? Yes. However, two reasons to use the unit circle. One, you get exact answers. If you put sine of 330 into the calculator, you're going to get a decimal. It's irrational, so it's never ending, and you're going to have to round it. So it's not going to be as exact as writing the -√3/2. Another reason. A year or two ago, I read in Forbes magazine that one of the big things companies like to look for are individuals who can read and interpret graphs. Now, I know the unit circle isn't something you're going to look at in companies that Forbes talks about. I actually can't imagine something that would specifically use the unit circle, but that's not the point. That is not the point. The point is teaching you how to read new and different graphs and pieces of information. So if you are successful in understanding this unit circle, you will continue to be successful looking at different sorts of tables and graphs of data, which can get you ahead in life, whatever company you choose to work for. So just a little tidbit there on why using the unit circle is a better idea than just plug and chugging into your calculator. Okay, I hope that was helpful. Let me know if you have any questions. Reach out to me or your teachers. Otherwise, have a wonderful rest of your day. Bye.